All right, now we're looking at example 5, where we have yet another three-part piecewise defined function. We're going to find 4 things in this case. Why not go out with a bang, because this is the last example for piecewise functions, at least until one of you guys suggests a new problem. So let's start with f of minus 1. f of minus 1, our input is minus 1. Which condition of these 3 does it meet? Does it live between 0 and minus 2? It turns out minus 1 does do that. So we're going to use the first function in this case. All right. So minus 1 is between 0 and minus 2. Use the first function. Every place I see an x, I'm going to replace it with a minus 1. So we have 1 over minus 1 squared plus 2 times minus 1 plus 1, all in the denominator. Simplify. We have 1 over 1, because minus 1 squared is 1, plus 2 times 1, which is, or 2 times minus 1. So that gives us minus 2 plus 1. All right, combining like terms as appropriate, combine all this, you get 1 over 0. Oh no, okay, so as mentioned in several videos ago, actually, 1 over 0. That tells us that f is not defined at minus 1. Sure, it met the first condition, but I couldn't actually plug it in to this first guy here. So f of minus 1 does not exist. Can't actually plug it in because we can't divide by 0. All right, maybe we'll get luckier in the second case. F of minus 3. Let's try that. All right, what condition does that meet? Does minus 3 live between 0 and minus 2? No. Does it live between minus 2 and minus 8? Yep. So I can plug that in to this second function. So every place I see an x, I'm going to replace it with a minus 3. In the second case, we have minus 3 plus 7. Combine everything, and you get square root of 4. Hey, look, that's 2. Sweet. Love when things work out nice. Especially when you invent them to do that. So we got the answer we're looking for f of minus 3. Let's try f of 0. Which condition does that meet? Does it meet the first one? Is x equals 0 strictly less than 0? Nope. X equals 0 is 0. We don't have an equal sign here, so we don't get to use the first condition. Is there a condition that has equals to 0? Oh yeah, look at that. This one. So x can be greater than or equal to 0 in order to use this function, which is 1 over square root of x. So what happens when I plug in? I have 1 over square root of 0. Oh no. So we have 1 over 0. And that tells me f of 0 is not defined either. Man, we're just not having a good day today with definition. So f of 0 is not defined or does not exist. Darn. All right. Lots of undefined things today. Tyler, you should pick better examples. Let's take a look at f of 1. What happens when I plug in 1? When x is equal to 1, where does it live? Does it live between 0 and minus 2? Nope. Does it live between minus 2 and minus 8? Nope. But it is bigger than or equal to 0, so we can use this guy. So I plug in 1 for this, and I have 1 over square root of 1, which is just 1 over 1, which is 1. Yay, so that's defined. We got something. So in 2 cases, we had does not exist. In 2 cases, we had it actually exists and it popped out a number for us. So 4 examples built into one big example number 5. Hopefully you found that helpful. And yeah, that's it for evaluating functions and evaluating piecewise functions. I'll see you in whatever video next that you need help with.